Now in this problem, we got f of t is equal to 3 secant squared pi t minus 1. Now what this really looks like is we got 3 secant of pi t minus 1, all of that to the second power. Now this is a chain rule. We got something to a power, so we'll take our power, put it out in front. What's inside the brackets in this case remains as is, and then we lower our power by 1, so the 2 minus 1 is 1, and then we multiply it times the derivative of what's inside our bracket, which is secant pi k minus t. So that's going to give us 6 secant pi k minus t times, now the derivative of secant is secant tangent, so that'll be, but this is a chain rule again, so we secant pi k minus t tangent pi k minus t times the derivative of what's inside the parentheses. Is that a, it's a T, not a K. What is it? P? Boy, my writing is really degenerate. That's T, T1, 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 and T1, if you can now read it. So we got 6 secant squared pi t minus 1. That's secant times secant. And we got tangent pi t minus 1. And derivative with respect to t, well, the pi t just becomes pi, and the minus 1 drops away. Now let's see how they simplify that. Okay, 6 pi secant squared this, and then they rewrite everything in terms of sine and cosine. Secant is 1 over cosine, so we can rewrite the secant squared as 1 over cosine squared pi t minus 1. And tangent is sine over cosine, so we can rewrite that as sine pi t minus 1 over cosine pi t minus 1 times pi. So then I got 6 pi sine of pi t minus 1 over cosine squared times cosine is cosine third pi t minus 1. And that's how they get that answer.